Hello, this is our video solution for problem 6 from Superquiz 1. This is very similar to one of the problems from one of our quizzes, where here we're trying to, just using a table of values for a function f, estimate the partial derivative of f at a certain point. In this case, we're looking at the point 2 comma 4, which in the chart, okay, there's our x, here's our y, so we're trying to figure out the rate of change of f at 2 comma 4 with respect to x. So this means that we're working in this direction here. All right. So what we have worked on in class is when you're trying to approximate a partial derivative using a table of values, ideally you actually want to use equidistant points to the left and to the right, right? Or if, say, we were going with a partial with respect to y, we would want to go from underneath towards up. All right. So we're actually going to use not the point in the middle, right, at 3.4, but the points to the left and to the right. So when we approximate this partial derivative, so we are, again, if this is with respect to x at 2 comma 4, this is going to be approximately, well, we're going to start by looking at how much the output has changed. So we look at fx at 2 comma, at 3 comma 4. So that's this point over here. And we're going to subtract f, excuse me. We're going to subtract f at 1 comma 4. Right? We want to see how much the output has changed from one side of the given point to the other. And then we divide by the distance that you traveled in the change, right? In this case, along the x-axis. So that would be 2. So in this case, f of 3 comma 4 is 2.4. F of 1 comma 4 is 2.6. 2.4 minus 2.6 is 0.2. And if you cut that in half, you get 0.1. So an approximation for the partial derivative is 0.1. Of course, we can't do any better than that in this problem because we don't have more precise values, right? We don't have things closer to 2 comma 4. We also don't have anything, even if we did find things that were closer, it might be an issue in terms of not having enough precision in our data. So this is about as good as we can hope to do.